Welcome back to Aurora Tech Channel. Last year I reviewed the K2 Plus, and that was the best Creality printer I have ever tested. After almost a year, it's still one of my most frequently used printers. It's fast with decent print quality, and the multiple filament CFS is also as reliable as the Bamboo Lab AMS. Creality recently released two smaller versions, the K2 Pro and K2, which price lower than the K2 Plus at $1,049 and $699, and today, we will test out the K2 Pro, which is the medium size in the K2 series. Let's first take a look at what the Creality K2 Pro has to offer. It's sold with the CFS multiple filament system as a combo priced at $1,049. It offers a 300 by 300 by 300 millimeter build volume and Core XY kinematics. The table space required is 18 inches by 23 inches, which includes the screen and room for the rear cables. The machine height is 23 inches. If you place the CFS on top, add another 11 inches, or 20 inches if you need space for it to fully open. The X-axis runs on a linear rail. The Y and Z axis use linear rods. The stepper motors on the X and Y axes, as well as the extruder, are closed loop. The extruder has a new high-flow design with a 70-watt heater and can boost flow rate up to 40 millimeters cubed per second. It ships with a hardened steel nozzle and a copper alloy heat break, and the maximum nozzle temperature is 300 degrees Celsius. The heated bed is 5 millimeters of aluminum with a maximum temperature of 110 degrees Celsius. The chassis is fully enclosed with a glass top, glass door, metal backboard, and metal base, giving the machine a net weight over 50 pounds. It also includes an actively heated chamber that can reach up to 60 degrees Celsius. In addition to the part cooling fan on the print head, there is an auxiliary fan on the left for extra cooling. The claimed top speed is 600 millimeters per second, with acceleration up to 20,000 millimeters per second squared. There is a filtered exhaust fan at the back to keep the internal temperature cool when printing low-temperature filament. Onboard storage has been increased to 32 gigabytes eMMC, so you can store more G-code files. It supports Auto Z offset and auto leveling, and it includes two cameras, one for remote print monitoring and one on the print head for flow and pressure advanced calibration. The CFS multi-filament system is included in the bundle. You can connect up to 4 CFS units to print up to 16 colors simultaneously. For network printing, it supports Creality's cloud service and also works over Ethernet and Wi-Fi, allowing you to keep prints on your local network or print completely offline from a USB drive. I would like to thank Creality for sending this machine and sponsoring today's video. Even though it's a sponsored review, we'll remain unbiased and point out any cons. With that said, let's get started. The machine and the CFS are packed in one box. The whole box is about 84 pounds. The top can be lifted off easily. The glass top was packed separately and attached to the right side of the machine. On top, there is a sample filament spool and a box with all the tools and accessories. The CFS is packed inside to save shipping space. You need to remove the plastic mounts to take it out. The Z-axis is secured with 4 screws, a pretty standard packing setup similar to the Bamboo Lab X and P series. There is not much to install since the machine arrived assembled. Just connect the screen cable and mount the screen at the front. You may not need the spool holder if you plan to use the CFS. Mount a hub at the back that allows you to connect up to 4 CFS units. You will also need Bowden tubes to feed filament from each CFS to the hub and then to the machine. 2 cables must be connected, one to the hub and one that runs all the way to the bottom of the printer. You can now connect power and turn it on. The setup wizard is the same as the K2 Plus. First select the language, then you get a reminder to remove all protective materials, followed by the agree to whatever it says screen. You can choose to connect via Ethernet or Wi-Fi. I connected to my own Wi-Fi network. It appears to support only 2.4 GHz networks. After connecting, it shows an IP address. Next, select the time zone, and if desired, your location to connect the machine to Creality Cloud. I won't set that up and will just use my local network. Then the machine performs a self-test. There is nothing you need to do, just sit back and wait. It checks the motion system, fans, heaters, calibration input shaper, and bed leveling. It finished in about 18 minutes. The screen UI is the same as the new generation Creality interfaces. It's basically identical to the K2 Plus. Okay, let's load some filament and start the first print. If you use Creality's Hyper PLA, the RFID tag will be read, and the filament type and color will be set automatically. Third-party filaments usually work well on the CFS. You need to use the screen menu to select the filament type and color one by one. We started with a simple 4-color Benchy, which has only 3 color changes, so it won't slow the print down too much compared with a single color print. The prep time took about 5 minutes and is not counted. The screen timer only starts once the machine begins printing. I let it print a few layers to reach top speed and did a sound test. With the door open, the noise level stays around the mid to high 50s decibels. With the door closed, it dropped to the high 40s and rose to the mid 50s during rapid movements. I also set the exhaust fan to 100% to help keep the internal temperature cool for PLA printing. With the exhaust fan at max, the noise increased by about 3 decibels to the low to mid 50s. Next, I timed the color changes. For a dark to light change, red to white, even though I actually switched to pink and yellow. I started timing when the current color stopped printing and stopped when the next color resumed. That dark to light change took about 2 minutes 38 seconds. For the light-dark change, yellow to blue, it took 1 minute 28 seconds, over a minute faster due to a smaller flush volume. The next change, blue to black, was in line with the last color change and took about 1.5 minutes. There were no more color changes after that, and we let the print finish. The print actually finished in about 35 minutes, but the machine completes filament cut and retraction before the screen timer stops, so the final reported time was 36 minutes, plus another 5 minutes of prep time, for a total of 41 minutes for this 4-color Benchy. The print quality was decent with good surface finish. Cooling at the front worked well since the front of the Benchy faced the auxiliary fan. The top also looked good. There was no under-extrusion, although the line width was a bit wider than normal because this sample G-code was optimized for speed. Overall, everything worked as expected. I will move on to more multicolor tests, then my benchmark and other material tests. For multicolor test prints, I'll start with the easiest one, expanding my Hello Kitty army. I'll do this 4-kitty print. When I tested this model on other single extruder, AMS-style machines, most suffered from color contamination. So I'll increase the flush volume to 1.3 times, which normally works well for this model. Estimated time is 14 hours 44 minutes. Our models are expected to use 186 grams with 18 grams for supports, so the model total would be around 200 grams. At 1.3 times flushing, the purge will be around 230 grams and the prime tower 30 grams, so total filament usage for this print will be about 460 grams. Let's note these numbers in the corner. If I change the flush volume back to 1.0 instead of 1.3, the estimated time remains 14 hours 44 minutes. It seems that when printing multiple colors, the slicer's estimated time isn't very accurate. For filament usage, the model with support, it uses the same 200 grams, but the purge is only 176 grams, while the prime tower remains 30 grams, so the total is about 410 grams. Therefore, we will flush 50 additional grams of filament to achieve cleaner color transitions. Let's switch back to 1.3 times flushing, start the print, and see how long it takes. By default, the bed temperature is set to 50 degrees Celsius for PLA, but because this is a long print and will run overnight, I'll raise it to 65 to be on the safe side. The CFS seems to work well. No jamming or feeding issues so far. Let's time some color changes for our own sliced model and see if there is any difference from the sample Benchy. We'll start with the pink to white change. Previously, the time for different color changes ranged from about 1.5 to 2.5 minutes. For this pink to white change, it took 2 minutes. Next, white to black. That change was faster, about 1.5 minutes. From black to white, I expect it to be much slower due to the extra flushing required when changing from a dark to a light color. With increased flushing, it took about 2.5 minutes. The filament change times are in line with our sample Benchy. The print took 17 hours to finish, about 15% longer than estimated. The result is very good. With 1.3 times flushing, there's no obvious color contamination, and the transitions are clean. Checking filament usage, the model with supports uses about 200 grams, closely matching the slicer's estimate. The purge is 218 grams, a bit less than the 230 gram estimate. The prime tower added 27 grams, also matching the 29 grams estimate. So the time estimate was off, but the filament estimates were quite accurate. Once the supports are removed, the kitties look beautiful. Upon close inspection, I noticed slight color contamination where the white and yellow meet around the neck. Increasing the yellow to white flushing to 2 times would be safer. Overall, it's barely noticeable and still quite acceptable from a normal viewing distance. Next, I started my second multicolor print, the Vegeta model. The challenging areas are the hair and forehead, so I began with a 1.3 by color change flush to see if we could get an acceptable result. The slicer estimated a little over 8 hours. There were 248 filament changes. The model plus supports were about 16 grams, and the purge, waste, and prime tower were 235 grams, making the total filament usage 253 grams. The print finished in 9 hours 26 minutes, about 16% longer than the estimate, in line with the Hello Kitty print, which was approximately 15% longer than estimated. Once again, the filament used was less than estimated. The color contamination on the forehead was obvious. 1.3 times flushing was not enough. I went back to the slicer. The current flush volume from gold to skin was 572, and the maximum I can set is 1,200, so I bumped it to the maximum. Because I only increased a single color's flush, the purge estimate increased to 214 grams, only about 10 grams more than before. Let's see if this improves the result. This print took 11 hours to finish, about 1.5 hours longer than the previous run. Comparing both prints, the forehead contamination is gone. We have a cleaner result this time. Checking actual filament usage for the second print, the model with supports was 15 grams, in line with the estimate. The purge, waste, and prime tower were 188 grams, less than the 245 gram estimate. That small change made a real difference. However, both models show a horizontal line near the top at the exact same height. When I printed another single color version of the same model at the same height, the line didn't appear, so it may be related to this model's G-code or a slicing issue when doing multiple colors. Next, I printed my version of the collapsible Master Sword. This model requires 3 to 4 colors per layer, so it's a good test for the CFS reliability. I added small supports at the overhangs and left the rest unsupported. I let the slicer show the overhangs and used the fill tool to add support in those 2 areas. For flush volume, I set it to 1.0 times instead of 1.3 times, since this model would generate a huge amount of waste even at 1.0 times. The model with supports uses only 172 grams, but the prime tower and purge waste would use almost 1,380 grams. The slicer estimated over 53 hours. Given that multicolor estimates are usually off, I expected the actual print to be around 65 hours. So I decided to try a different approach and see if we can save some time. Instead of printing the sword in one piece, I removed the blade and printed it separately in white. After removing the blade, the estimated time dropped to about 41 hours, saving roughly half a day because the number of color changes decreased by about 400. Since any color white change takes at least 2 minutes, reducing 400 changes saves approximately 800 minutes, over 13 hours. Filament waste was slightly reduced, approximately 50 grams, but the main benefit was time savings. I sliced the blade as a single white part with no waste. It took only 2.5 hours, so printing the 2 parts separately should save at least 10 hours. I started with the blade. As expected, it was a simple print and took 2 hours 40 minutes. Then I started to print the sword body. After more than 40 hours, I tried to clean the waste bin at the back, but accidentally trapped the power cord. Fortunately, the printer has power resume. I let it continue. Since the print was already on the bed, the printer homed using sensorless homing instead of the nozzle probe and resumed printing. I'm glad it continued. The print finally finished in 57 hours and 17 minutes, almost 40% longer than the slicer estimate. It seems that the more color changes a print requires, the more the estimate can be off. The model itself weighed 163 grams, which closely matches the estimate. The prime tower was 87 grams, close to the 92-gram estimate. The purge waste was 1,167 grams, about 13% less than estimated. The area where the print resumed is not perfect, which is expected to see something like that after using power resume, but this time I found this feature truly useful. At least I didn't have to restart the 57-hour print. The sword slides out very smoothly. Next, I ran some benchmark test prints, starting with the number slider clearance test. Most latest gen printers can print this model without issues, so I expected the K2 Pro to do the same. The print finished in 2 hours 21 minutes, faster than the average of 2 hours 30 to 45 minutes. The top is clean with no stringing at all. The bottom stuck nicely to the bed, and there are tiny gaps between the tiles. The tiles can move as expected. Then I printed the Honeycomb box to test extruder retraction. It handled the job well, extruding only a tiny amount of filament before moving to the next spot without stringing. The print finished in 2 hours 24 minutes, which is about average. Because this print doesn't have much room for acceleration, most printers finish in nearly the same time. The honeycomb pattern is very clean and printed without broken sections. Some of the bottom patterns were slightly squeezed low, but that's common for this model. Overall, the K2 Pro's quality is in line with other good printers. Most printers can't print a perfect bottom. There's usually some slight squeeze, but it's still within an acceptable range. Next, I printed the tolerance model to see whether the parts fit. The print finished in 1 hour 12 minutes, slightly faster than the average 1.5 hours. On the square side, it cleared up to 0.1 millimeter, but got stuck at 0.075 millimeter, which is below average. On the cylinder side, it cleared up to 0.05 millimeters and stopped at 0 millimeters, which is a perfect score. This suggests the flow is spot on, but the pressure advance needs calibration. I was using Creality Hyper PLA and assumed the profile had the optimal PA, but that wasn't the case. I used the screen menu, went to print settings, enabled PA calibration, and also enabled flow calibration. The printer printed a pattern on the left and used the camera to calibrate pressure advance, plus a long bar on the right for flow calibration. The screen timer still showed 1 hour 12 minutes because it doesn't count prep and calibration time. After calibration, the square side cleared up to 0.05 millimeters and stopped at 0. The cylinder side did the same, so it achieved a perfect score after pressure advance calibration. Then I printed the Robo Alpaka for a surface quality test. The model has more room for acceleration in the middle, but it didn't print as fast as my K2 Plus, which I use a lot. Still, I let it finish to compare quality and time with other machines. It finished in 4 hours 7 minutes, faster than the average 4.5 to 5 hours, but almost 50 minutes slower than the K2 Plus. The print quality is similar to the K2 Plus, but the K2 Plus is faster, likely due to higher acceleration and dual auxiliary cooling. Compared with the Prusa Core 1, the K2 Pro is faster and has slightly better surface quality. Compared to the Bambu Lab X1 Carbon, the times are similar, but the X1 Carbon surface is a bit better. Compared with the H2D is slower, about 27 minutes, because of the weight of the dual extruder on the head, though its surface quality is better. Next, I tried different materials. Starting with PETG, I printed a trash can with 3 bottoms and 3 walls at 0.28 millimeters layer height. The print finished in 5 hours 24 minutes. There was some stringing, which is normal for PETG. The bottom looked good, and the top remained consistent with the bottom. The inside of the trash can was fairly clean with minimal stringing, and the bottom printed beautifully. Because this printer has a heated chamber, I tried ABS without glue. This model also requires excessive retraction, similar to the Honeycomb box. The print finished in 3 hours 10 minutes. There was no warping or layer cracking. The bottom was slightly squeezed low, showing a bit of elephant's foot in the first few layers, but the sides printed fine with no layer cracking. Aside from the first layer squeeze, the bottom was actually printed pretty well, even without using glue. I also tried an engineering grade material. I printed a holster belt clip for my dad using PETCF as both the part and the support to avoid expensive soluble supports on a single extruder printer. I put glue on the bed so the PET won't stick too well. The glue will act as a release agent. The print finished in 1 hour 48 minutes. The tree supports were easy to remove, and the result was good. The part serves its purpose well as a holster belt clip. Finally, I ran a first layer test by printing a PLA sheet. It finished in 31 minutes. The sheet peeled off in one piece without line separation. The top surface is beautiful. The only imperfection is one corner I damaged while scraping it off the bed while it was still warm. My fault. The bottom is also excellent. This is much better than average, and definitely one of the best first layer tests I've had so far. Let's talk about the pros and cons of this printer, starting with the pros. 1. The build quality of the K2 Pro is top-notch. Its motion system pairs a linear rail on the X-axis, linear rods on the Y and Z axes with core XY kinematics, a configuration well-suited for fast, precise printing and easy maintenance. The machine is heavy-duty, over 50 pounds, and uses a rigid metal backboard and base to reduce vibration. Overall, the hardware is solid and delivers better than average print quality and speed. The X and Y axes, along with the extruder, use closed-loop motors that continuously monitor position, detect missteps, and correct them automatically. 2. Pressure, advance, and flow are calibrated using the secondary camera on the print head, and this noticeably improves print quality. With calibration disabled, tolerance degrades to about 0.1 mm at high speeds. With pressure advance calibration enabled, the printer reliably clears down to 0.05 mm, earning a perfect score on the tolerance test. 3. With the actively heated chamber, the printer produces excellent ABS prints without glue. Set to 60 degrees Celsius, the chamber reached 50 degrees Celsius in about 15 minutes and hit 60 degrees Celsius after roughly 50 minutes. I experienced no adhesion or warping issues. The only imperfection was a slightly flattened first layer, likely caused by the high bed and nozzle temperatures, so the auto-Z offset may need better tuning at high temperatures to compensate for heat expansion. 4. A 5 mm aluminum heater bed offers several advantages over a standard 3 mm bed. The extra thickness improves heat distribution across the surface, reducing warping, especially on larger prints. The added rigidity also makes the bed more resistant to bending or warping over time, and it improves energy efficiency by minimizing the need for frequent reheating. 5. The exhaust fans, fitted with carbon filters, vent air outside to help maintain a cool internal temperature. Because the printer is fully enclosed, you don't need to remove the top or open the door when printing PLA or other low-temperature materials. 6. The CFS multi-filament system performs very well. It handled large prints like the Master Sword with over 1,000 filament changes and matches the Bambulab X1 Carbon in reliability while offering a few small improvements. The filament inlet is extended a few inches to prevent steep feeding angles when a spool is nearly empty, and I experienced no errors or jams with a wide range of brands. When using Creality filaments with RFID, it automatically sets the filament type and color. It also has a small display that shows temperature and humidity, plus a CFS unit number that's useful when running multiple units. 7. The new Orca Slicer-based Creality print performs much better than previous Cura-based versions. It's now comparable to major slicers like Prusa Slicer and Bamboo Studio, addressing a key weakness of earlier Creality machines. Other small improvements include upgrading the standard 8GB to 32GB eMMC, and also stores more time-lapse videos without the need to delete them regularly. Now for the cons. 1. The K2 Pro inherits most of the K2 Plus's features, but comes at a lower price and with a slightly smaller build volume. It's a solid value, but there are trade-offs. The K2 Pro's top speed is marginally lower. Acceleration is reduced from 30,000 mm per second squared to 20,000 mm per second squared. The K2 Plus's dual auxiliary fans are replaced by a single auxiliary fan on the K2 Pro, and hot and power drops from 100 watts to 70 watts. Maximum nozzle and bed temperatures are 300 degrees Celsius and 110 degrees Celsius on the K2 Pro versus 350 degrees Celsius and 120 degrees Celsius on the K2 Plus. Other differences include a 720p camera instead of 1080p, no 5 GHz Wi-Fi, and a single exhaust fan rather than dual exhausts. The only missing feature that caused an issue in my tests was the auto belt tensioning. During a CFS filament change, the cutter initially didn't slice cleanly. I didn't hear the crisp cut, which led to unloading doctoral loading problems. After I manually adjusted the belt tension and recalibrated the cutter, the CFS worked flawlessly. I didn't encounter this issue with the K2 Plus. It printed well out of the box. This is a bad idea to remove such a useful feature. It doesn't save much in cost, but could potentially have a huge impact. If a user is new to the K2 and CFS platform and encounters multiple errors on their first color print, they may not realize the fix is simple, become frustrated, and in the worst case, return the machine and leave negative feedback as an angry customer. 2. The CFS has a curved top, not as pronounced as the Bambulab AMS, but it is still unstackable. Using multiple units still requires extra table space. It lacks built-in filament drying features found on the AMS2 Pro and some newer AMS clones. Instead, it functions as an airtight storage box that uses desiccant to keep filament dry. 3. Last year, the K2 Plus launched when many users were hoping for a larger Bambulab X1 Carbon. Because Bambulab didn't deliver, the K2 Plus filled the gap and gave users what they wanted. It was a huge success. Almost a year later, the K2 Pro performs nearly on par with the K2 Plus. However, several new machines, including the Bambulab H2D and H2C and the Snapmaker U1 with its multi-tool changer, have since appeared. The K2 Pro is essentially a smaller, lower-priced, feature-reduced version of the K2 Plus with no real innovations, so it's less exciting than the K2 Plus was last year. Don't get me wrong, it's still a good printer and outperforms other AMS variants and clones I've tested, but the market is very different now, and Creality will need some real innovations to keep up. In conclusion, the K2 Pro is well built. Creality CFS on the K2 platform is one of the few reliable single extruder multi-filament systems and outperforms almost all other AMS variants. If you don't need the extra build volume of the K2 Plus and can live with a few minor feature reductions, the K2 Pro is a great option. Although it's smaller than the K2 Plus, it's still bigger than the Bambu Lab X1 Carbon, comes at a lower price, and performs on par, so it represents a strong value. If you want a larger build area, higher nozzle and bed temperature limits for broader material compatibility, faster print speeds, a higher flow hot end, extra cooling, and additional add-ons and upgrades, the K2 Plus is the better choice, and the $250 premium may be worth it. I personally prefer the K2 Plus, and it's currently ranked number 2 on my recommendation list. Although the K2 Pro doesn't introduce new features and didn't surprise me the way the K2 Plus did last year, its reliability and performance are still solid. I will add it to my recommendations as the best performing multicolor, fully enclosed high-speed 3D printer in the regular plus size category. Currently, only 15 printers are on that list out of nearly 200 machines we've tested, and the list is updated regularly. If you're interested in the K2 Pro or K2 Plus, I put their links in the video description. Also, check out AuroraTechChannel.com for up-to-date price tracking on 3D printers, laser engravers, and CNC machines. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.